Welcome everyone to Digital Learning by the Department of Collegiate Education. I am Manjunath CV, working as Assistant Professor at Government First Grade College, CS Pura, affiliated to Tumkur University. And I am here before you to present the topic Regression Analysis, which is a part of chapter number 2. This chapter number 2, Regression Analysis, is spread over 8 sessions. Therefore, there will be 8 videos which will help you to thoroughly understand the chapter Regression Analysis. This is a part of the subject Quantitative Analysis 2. So let us proceed further and try to understand the theoretical concepts, the foundations of what exactly do we understand by regression. What is the meaning of regression? What is the definition of regression? What is regression analysis? What is regression equations? In this process, what are regression coefficients? What are the assumptions of regression analysis, and so on? And these theoretical aspects are very important, dear students, in order to properly understand or properly solve the problems. The theoreticals are like the fundamentals which form your strength to solve the problems, to interpret the results, and to understand the analysis. Now, regression analysis. Before I proceed to regression analysis, there are 3 important terms here we need to understand. The one is covariance, which measures directional relationship. Correlation, which is an indicator of the strength of the relationship. And regression, it is the average relationship. So before proceeding to regression analysis, let us throw some light on covariance and correlation. When I come to these 2 concepts, covariance and correlation, we have already seen these concepts in chapter number 1, correlation. Covariance only measures the directional relationship between 2 variables. Now, what do we mean by directional relationship? Directional relationship means the relationship between the 2 variables, let us say x and y, is indicated only through the direction. For instance, let us take 2 variables. One is the oil prices and the second one is the air ticket prices. And we all know that air ticket prices are directly dependent on the oil prices. So there are 2 variables. One is the oil prices and the second one is the air ticket prices. If oil prices increase, will the air ticket prices increase? Question number 1. Second, if the oil prices decrease, will the air ticket prices also decrease? Situation number 3. If oil prices increase, will air ticket prices decrease? And if oil price decrease, will air ticket prices increase? This is what we are trying to understand. How do the 2 variables function with each other? For example, if oil price decrease and air ticket prices also decrease, they are moving in the same direction. And if oil prices increase and air ticket prices also increase, again they are moving in the upward direction, that is the same direction. But when they move in the opposite direction, then we state that they are moving in the opposite direction. So this direction in which they are moving, either in the same direction or in the opposite direction, can be identified with the help of covariance. So this covariance clearly measures only the directional relationship, whether they are moving in the same direction or they are moving in the opposite direction. Now, when they move in the same direction, that is when we call it as they are positively correlated, which means if x increases, y also will increase, and if x decreases, y also will decrease. This is positive correlation. They are related positively. Now, what is negative correlation? If one increases and the other decreases, that is when we state they are moving in the opposite direction and they are negatively correlated. Or if prices decrease, demand increases, again it is an opposite direction. One is decreasing, the other one is increasing. So they are in the opposite direction. So covariance clearly gives us only a picture of what is the movement of the direction. It does not throw light on a mathematical figure or on any average or any numerical value. It just says both are increasing, both are decreasing. For instance, if x increases by 50%, covariance does not state whether y also increases by 50% or whether it is increases by 40% or whether it increases by 10% or whether it increases by 80%. There is no mathematical figure given there. That is why it is mentioned clearly, covariance only measures the directional relationship. A step further is correlation. It's a better indicator of the relationship between the variables because it focuses on the strength of the relationship. In other words, it gives a mathematical figure to the relationship. We had seen three different methods: scatter diagram, Karl-Pearson's correlation, and Spearman's rank correlation. Scatter diagram again was only a directional relationship, whereas Karl-Pearson's coefficient of correlation gave a specific mathematical value to this correlationship. This mathematical value strengthens the relationship between the variables. Therefore, correlation is a better indicator of the strength of the relationship. Now, depending on these two factors, covariance and covariance, we can further measure the relationship between these two variables, and that measure is called as regression. Regression is a measure of the average relationship between the two or more variables in terms of original units of data. Further, the value of an unknown variable, which is called as generally the dependent variable, is found out with the help of a known variable, and this known variable is called as independent variable. We all know that we are searching or finding out the relationship between two variables or more than two variables. Let us take the example of price and demand, and let the commodity be gold, for instance. When the price of the gold is 5,000 rupees per gram, what happens to the demand? Right? Similarly, when price increases from 5,000 to 5,200 rupees, will the demand also increase or will it decrease? This is what we are finding out with the help of correlation. Now, in regression, we are trying to find out if price decreases by, let us say, 10%. From 5,000, it is decreasing by 10%, that is 500 rupees. Let us say the price of new gold is 4,500 rupees. What is the percentage change in demand? Is it a proportionate increase or proportionate decrease, or is there a difference in the percentages of increase and decrease? Can be identified with the help of regression. That is why when we know the value of one variable, that is the known variable, or we can call it as the independent variable. For instance, here I said price is decreasing from 5,000 rupees to 4,500 rupees. I have defined that variable that it is decreasing by 10% or 500 rupees. So when I know that price is decreased, I can identify will the demand increase or will the demand decrease. If it is going to increase or decrease, by how much percentage it is going to increase or decrease. That is why it is stated. Further, the value of an unknown variable, that is the demand, is found out with the help of a known variable, which is the price. Hence, price is an independent variable and demand is the dependent variable in this example. Now, how do we find these relationships? That is with the help of regression analysis, the name of the chapter. So we know that there are two regression lines, and similarly there are two regression equations. One equation is the equation of x on y, and the other equation is the equation of y on x. So let us look into this in the further slides. Meaning of regression. What is regression? Regression is a statistical tool with the help of which we are in a position to estimate the value of an unknown variable from the known values of another variable when the two variables are closely related or interrelated. This previous example which I took, what happens to the demand in gold when the prices in gold decrease or when the prices in gold increase. Therefore, it is a statistical tool, regression, which helps us in identifying or estimated or finding out or predicting the value of the unknown variable with the help of the known variable. And the unknown variable is known as dependent variable and the known variable is called as the independent variable. When was this term regression actually found? It was first used by a British biometrician, Sir Francis Galton, towards the end of the 19th century in a research paper which he had published. And the name of the paper was Regression Towards Mediocrity in Hereditary Stature. Here, Sir Francis Galton tried to study the relationship between the heights of fathers and heights of the son. Is there a relationship between the height of the father and height of the son? For instance, if the father is tall, will the son also be tall? If the father is short, will the son also be short? Or is there a negative correlation between the father and the son? So that is what Sir Francis Galton tried to understand, and in this process of understanding and explaining the relationship between height of father and son, Sir Francis Galton first time used the word regression analysis. Definition of regression analysis. Richmond defined regression analysis as regression is a technique for the derivation of an equation by which one of the variables, that is the dependent variable, may be estimated, may be calculated, or may be found out from the other variable which is known as the independent variable. This is what we also have been trying to understand with the help of our previous slides. Further, in the words of M. Blair, he defines regression as regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of data. These are the two widely used definitions of regression analysis. Now, what is the meaning of regression analysis? Regression analysis is a technique which measures the average relationship between two or more variables, and further it helps us in estimating the value of the unknown variable, that is the dependent variable, for a given value of the independent variable, that is the known value of another variable. If we know x, we can find out y. If we know y, we can find out x. Similarly, the relationship between supply and demand. As the demand increases, the supply also increases. And as demand decreases, supply also decreases. The general relationship between demand and supply. So if we know the supply is high, automatically we try to increase the demand. And if we know that the demand is less, we automatically try to reduce the supply. Next, dependent variable and independent variable. This is the most important part in understanding what is dependent and what is independent. In simple words, whatever we are trying to find out, the variable values which we are trying to find out, that is called as dependent variables. And the value of another variable which is already given in the problem, that is called as independent variable. For example, which I took in the previous session, the relationship between the prices of oil prices and the air ticket prices. Oil prices is one variable, air ticket prices is another variable, and as we said, as the oil prices increase, air ticket prices also increase. right? If oil, so that relationship is nothing but identifying dependent and independent variable. In regression analysis, there are two types of variables, namely the dependent variable and the independent variable. Dependent variable is one whose value is influenced by the other variable. I repeat once again, dependent variable is one whose value is influenced by the other variable. In other words, the variable which is to be estimated, or the variable which is to be predicted, or the variable which is to be found out is called as the dependent variable. In regression analysis, the dependent variable is also known as regressed variable, explained variable, or the predicted variable. Now, what is the independent variable? Independent variable is one which influences the value of the other related variable. In other words, the variable which is used for prediction or estimation is called as the independent variable. In regression analysis, the independent variable is also known as the regressor or explainer or predictor. For instance, if we know the relationship between the selling price and demand for a product, we can find out the quantity demanded at any given price, right? Similarly, we can find out what will be the sales if the price increases or if the price decreases. Therefore, here we are estimating demand at a given price of the product. Demand is called the dependent variable and price is called as the independent variable. So I hope you have clearly understood and differentiate between what is a dependent variable and independent variable. Next, regression coefficients. What is this regression coefficient? The rate of change of variable for a unit change in the other variable is called as regression coefficient of the former on the later. For example, if a 10% change is there in the price of gold, what will happen to the demand of the gold? Will it fall by 10%, or will it fall down by 20%, or will it increase by 20%? Will it increase by 30%? This percentage change or the amount of change or the rate of change is what is indicated or measured by the regression coefficient. So I repeat it once again. The rate of change of variable for a unit change in the other variable is called as the regression coefficient of the former on the later. And we all know, since there are two regression lines, there are two regression coefficients. One regression coefficient of x on y is called as bxy, and the regression coefficient of y on x is called as byx. Now, bxy and byx, there are certain formulas to find out bxy and byx. Bxy is equal to coefficient of correlation, that is r, into standard deviation of x divided by standard deviation of y. Similarly, the regression coefficient of y and x is denoted by byx, and byx is equal to r into standard deviation of y divided by standard deviation of x. Further, we also have two further formulas, different formulas, when we have to calculate bxy from the actual mean and bxy from the assumed mean. So regression coefficients bxy and byx are found out through the different formulas depending on the nature of the data which we have in the problem. What are the assumptions of regression analysis? Number one, there is an existence of actual linear relationship. Second, the regression analysis is used to estimate the values within the range for which it is valid. Third, the relationship between the dependent and independent variable remains the same as long as the regression equation remains the same. Further, the dependent variable takes any values, any random values, but the independent variables are fixed. Because we have defined the independent variable is going to decrease or it is going to increase for a given particular decrease or increase, what is the change in the other variable? Therefore, dependent variable takes any random values, whereas the independent variable takes only fixed values. Further, in regression, we have only one dependent variable in our estimating equation. However, there can be more than one independent variables. So in this session, we have tried to learn what is regression analysis, what is the meaning of regression analysis, the independent variables, dependent variables, regression coefficients, and assumptions on regression analysis. Now, in the first video, I am also going to discuss certain theoretical aspects of the session number 2 also. Hence, this video will hold good for session 1 as well as session 2 because I am covering both the aspects of session 1 as well as session 2. Welcome to session 10. This is the second session on the chapter 2, which is regression analysis. And in this topic, we're going to discuss about what are the utilities in regression analysis, what is regression analysis, and what is the importance of regression analysis. This is a part of the chapter 2 regression analysis in the subject quantitative analysis 2. What are the uses of regression analysis? What are the utilities in regression analysis? Regression analysis is used in all those fields where two or more related variables are having the tendency to go back to the average. Second, it predicts the values of the dependent variables from the known values of independent variables. So if there are two variables and if they are correlated, you can find out the value of one variable when you know the value of the other variable. For instance, let us say there are two regression equations x and y. If you know the value of x, you can find out the value of y. And if you know the value of y, you can find out the value of x. That is the main use of regression analysis. Further, it is used in the statistical estimation of the demand curve, supply curve, production functions, cost functions, consumption functions, etc. to study the correlation with the help of regression. What are regression lines? These regression lines nowadays are also known as estimating lines. The line of regression is a straight line which gives the best estimate of one variable for any given value of the other variable. For instance, if I am trying to find out the regression line of x on y, I am going to get the best fit for the variable x for a given change in the variable y. If y changes by 10%, 20%, I can identify what is the percentage of change in the variable x. So for a given change in y, I am estimating what is the change in x. This is called as the regression equation of x on y or the regression line of x on y. I repeat once again, the line of regression is a straight line which gives the best estimate of one variable for any given value of the other variable. Let us assume we have been given the values of y, therefore we can easily find out the best estimate of x for a given change in y. So regression line is a graphical technique to show the functional relationship between the two variables, that is x and y, out of which x is the dependent variable and y is the independent variable. Or it could also be the other way around. When the regression line of y on x, y is the dependent variable and x is the independent variable. So these two variables x and y interchange, and when they interchange, we change them. The dependent and interdependent variables are also changeable. Therefore, it shows the average relationship between two variables X and Y. And nowadays, experts prefer to call it as the estimating line because it gives an approximate idea, it gives an approximate estimate of what could be the change in the dependent variable on the basis of change in the independent variable. So if independent variable changes, definitely there should be a change in the dependent variable, and to what extent is this dependent variable going to change is indicated by the regression lines. Definition of regression lines. According to J.R. Stockton, the device used for estimating the value of one variable from the value of the other consists of a line drawn through the points in such a manner as to represent the average relationship between the two variables. And such a line is called the line of regression. It is more or less whatever that we have been trying to understand in terms of regression equations and regression lines. Two variables, one is dependent, one is independent. If you know the value of independent variable, you can easily find out what is the value of the dependent variable. In case of two variables, x and y, as stated earlier, we shall have two regression lines. The regression line of y on x and the regression line of x on y. The regression line of y on x gives the most probable value of y when the value of x is given. Therefore, y is dependent, x is independent. If you take the regression line of x on y, x will be dependent, y will be independent. In simple words, the value which you are identifying, the value which you are predicting, the value which you are estimating, that variable is called as dependent variable because it is depending on the change in another variable, and that variable is called as independent variable. So when I talk of regression line of y on x, y is depending on x. So the former, which is y, is depending on the later, that is x. For a small change in x, what is the change in y? Therefore, x is the independent variable and y is the dependent variable in case of the regression line of y on x. Similarly, the regression line of x on y. So here we are trying to find out the value of x for a given value of y. So y's value is known, x's value is unknown. So we are finding out the unknown value of x for a change in the known value of y. Hence the known value, which is y, which is called as the independent variable, and x is called as the dependent variable. If y increases by 50%, what is the change in the variable x? So x is depending on y, hence y is the independent variable and x is the dependent variable in case of the regression line of x on y. I hope you are all able to clearly differentiate between what will be the dependent variable and what will be the independent variable in case of regression line of y on x and regression line of x on y. And similarly, there will be questions for 15 marks or 5 marks asking you to find out the marks of students in two different subjects. Let us say we are comparing the marks of students secured in statistics and marks secured in accountancy. So if a student secures 50 marks in statistics, what is the marks he is likely to score in accountancy? You will get these types of questions. So you know the value of one variable, which is statistics. You have to find out the value of another variable, which is accountancy. What if he scores 17 statistics? What will be his marks in accountancy? So the identification or prediction or estimation or calculation of the value of an unknown variable with the help of a known variable is the main purpose of regression analysis. So that is why we have to study the two regression coefficients, the regression equations, and what is the coefficient of correlation between all these to understand better how the two variables are reacting. Are they reacting positively or are they reacting negatively? And what is the extent of change in one variable for a given change in the other variable? So what do these regression lines signify? The farther the two regression lines from each other, the longer is the degree of correlation. And the nearer the two regression lines to each other, the higher is the degree of correlation. If both the variables are independent, which means x is not dependent on y is not dependent on x, therefore both variables are independent, regression is zero. That is what we discussed in the previous chapter. Correlation lies between -1 and +1. If correlation is -1, it is a perfect negative correlation. If correlation is +1, it is perfect positive correlation. What if correlation is 0, which means there is no relation between the two variables? Therefore, when both the variables are independent, none of the variable is dependent on the other, and that is when regression is 0. And at that point of time, the lines of regression will be parallel to each other, which is OX and OY, and therefore they will be absolutely right angles. For two variables x and y, there are two lines of regression. Regression line of x on y and regression line of y on x. Regression line of x on y gives the best estimate or best prediction for the value x when they have given a specific value y. And regression line of y on x gives the best estimate for the value y for a specific value of x, which we have already discussed even in the previous slides. So that's all for this session. We have tried to understand utilities in regression analysis, what's regression analysis, and significance of regression analysis. Thank you all.